Okay, question 17 from the Tech Free 2023 Maths Methods paper. So, question 17. A chemical is added to the water in a swimming pool at 10 a.m. to prevent algae. So that's our starting time. The amount of chemical absorbed into the water over t hours is represented by A equals 10t squared minus 4t cubed between 0 and 1 2/3 hours. So, determine the time of day when the rate of absorption of the chemical is at its maximum. And we're looking at when the rate is at its maximum. Use calculus techniques to verify your time corresponds to a maximum rate. So we've got our equation. So our first step is we want an equation for the rate of absorption. So we've got the amount of absorption. We want to do the derivative to get to the rate. So when we do A dash, we'll get 20t minus 12t squared. Now we want to know when this equation is at a maximum. So we need to do the derivative of that again to find out when the rate is at a maximum. So when we do the derivative again, we get 20 minus 24t. And when the rate is at a maximum, that will be equal to 0. So we will be looking for when that's equal to 0. So 24t is equal to 20. So our t is 20 on 24, which we can simplify to 5 over 6 hours. Now 5 over 6 hours is obviously 50 minutes, which then we know that's after 10 a.m. So that would be 10:50 a.m. Now we want to also use calculus to verify that our time corresponds to a maximum rate. So to check if it's a maximum, we would do the double derivative to find that out. Now because we're starting with the first derivative, to do the double derivative, there's 1, we need to go again, and we would get that we're looking for the derivative of 20 minus 24t, which is going to be minus 24. Now there's no variable there, so our answer is just minus 24. If we get a negative, we know that that is a maximum. So then we're able to confirm that 10:50 is when the rate is at a maximum. For question 18, we are looking at quite a complex question. So we've got 18 and 19 are our last two on the paper. So we are, obviously these are going to be our most complex questions that we will see in the paper. We've got a person enters the lowest carriage of a miniature Ferris wheel with a 6-metre diameter. The bottom carriage is 1 metre off the ground. When top speed is reached, it takes 3 seconds for a carriage to travel from the lowest to the highest point of the ride. And then we've got a claim about the acceleration. Now what we need to think about in this is that we've got our Ferris wheel, we've got our 6-metre diameter, we've got the person entering, and they are going round. So they're starting at the lowest point, they are coming up to the highest point, and then coming back down again. So we've actually got a cos curve, and that's one of the key things that you need to identify in this question, is that we're looking at a cos curve. So we know that the maximum distance in that cos curve is 6 metres, but we're starting at 1 metre, which means our then mean value is going to be 4 metres there, going up to 7 and down to 1. We also need to remember that it takes the 3 seconds to get from the lowest to the highest point. That's 3 seconds. So then our total would be the 6 seconds for the period for that function. So we know a few things. We know that the amplitude is going to be 3 because we're going from 4 up to 7 and down to 1. So amplitude's 3. Our mean value is equal to 4. And we know that the period is 6 seconds. That means we can work out b, because we know that the period is equal to 2 pi on b. So if 6 is equal to 2 pi on b, then we can say 6b is going to be equal to 2 pi. So b is going to be 2 pi on 6, which we can say is pi on 3. That then gets us our equation. We can also see that it's not our straight cos curve, because our cos would start at the top and go down. So it's the flip of that, which means we need a negative. So our equation then becomes negative and we put our amplitude in front, 3 cos of pi on 3 x, or we might do t because it's time, and then plus 4 because it's all shifted up 4 there. Then we need to look at more about what the question's looking at. So we're looking at the vertical motion, vertical acceleration. So we've got the position here. So we need to do the derivative to get the velocity and then do it again to get the acceleration. So when we do the derivative here, obviously we're bringing out that pi on 3. So, and remembering that cos goes to negative sign, so that will become a positive at the front now. And we'll have our positive 3 times pi on 3 sine pi on 3t. So we'll reduce that to just pi sine pi on 3t. Then to get the acceleration, we're going to do the derivative again. So then that will become pi on 3 times pi. And that will go to cos pi on 3t. So that then here will become pi squared on 3 cos of pi on 3t. Now, when we're thinking about that curve, we know that the amplitude gives us the maximum. So if we're talking about the equation for acceleration, then this amplitude here is going to tell us the maximum acceleration that is going to experience. This is where we then need to evaluate this claim that it's going to be more than half of the acceleration of free fall. And we've been told that free fall is the 9.8. So half of that, obviously you're looking at about 4.9. Is this number here going to be more than 4.9? Now we can't, it's tech free, so we obviously can't find the exact value for that. We can make an estimate though. So pi we know is 3.14. We can approximate that to about 3 and do 3 squared over 3, which will be 9 on 3, which is 3. Obviously it's going to be a little bit higher than that, but we want to compare that to say 4.9, and we're not going to get to 4.9 even with our 3.14, which if you wanted to go to the point of going 3.14 times 3.14 and getting a closer estimate, you could, but it won't get to the more than the 4.9 up there, and so that's the part you'll need to write and when you evaluate that reasonableness of the claim there. Okay, then we get to the last one on the paper. So, question 19. We've got Jackson and Shari each own a shop and have recorded the number of customers entering their shop on 2 consecutive days. We've got that the number of daily customers for each shop is modelled by the equation here, where x and y is the number of x is the day number, and y is the number of customers, and the constants a and b are different for each shop. We want to determine algebraically whether the total number of customers will be the same every day in the future, because when we look at it here, day 1 it added to 50, day 2 it added to 50. Is that going to be the same every day? So obviously we need to solve for a and b in each of those and then put them together as the total. So starting with Jackson, we've got 40 and 30. So we're going to put that into the y equals a ln bx equation. So starting with the 40, we have 40 is going to equal a ln of b times 1, or just b. Then when we put in the 30, we've got 30 is going to equal a ln of b times 2, or 2b. So here we've obviously got a ln b and we've got a ln of 2b. We want to be able to solve these simultaneously. So what we can do with this one is actually split it up and make it a ln of 2 plus a ln of b, so that when you would combine them, you would get 2b. And so once we've done that, and that is the key part to this question, recognizing this skill that you can do, is that you now have a ln b, and you can take this 40 and pop it in there to get a ln 2 plus 40 is equal to 30. Then you can take the 40 over and you get negative 10 is a ln 2. And then to get the a on its own, you've got negative 10 is, take negative 10 over ln 2 is going to be equal to a. Once you've got the a, you can pop that back into your equation here to solve for b. So then you've got your 40 is equal to a ln b, and you've got 40 is going to be equal to negative 10 on ln 2 ln b. Then to rearrange that, we can obviously bring over that 40 divided by negative 10 on ln2 is going to be equal to lnb. Then when we're dividing like this, we can bring that ln2 up to the top. So we have 40 ln2 over negative 10 is equal to lnb. Then we can do the 40 divided by negative 10 is going to just give us negative 4 ln2 is equal to lnb. And then we can bring that negative 4 up to the top to make that ln2 to the negative 4 is equal to lnb. Now we can equate those parts there, and b is equal to 2 to the negative 4, which we know is the same as 1 over 2 to the 4, which is the same as 1 over 16. So we now have the b and the a for Jackson. This is a long question. So Jackson's equation then is, and I'll bring that over, I think we've got another spare, got a piece of paper here, we'll write him over here, y is equal to negative 10 on ln2, and that will be ln of 1 on 16x. So that's now into our equation. Then we want to start on Shari, and we're going to do the same thing again. So Shari starts with 10 is equal to a ln b, and we've got 20 is equal to a ln 2b. Then we're going to obviously do the splitting that we did for the other one, ln of 2 plus a ln of b. Then we're able to put that 10 in over there. So we get 20 is equal to a ln 2 plus 10. We can take the 10 from both sides. 10 is equal to a ln 2. So our a is going to be 10 on ln 2. Then we can solve for b for Shari by putting that into the 10 is equal to a ln b. So 10 is going to equal 10 on ln 2 ln b. Bringing that, getting the ln b on its own by dividing by the 10 on ln 2. That ln 2 comes to the top, 10 ln 2 over 10 is equal to ln b. Then we can cancel that 10 out, so we get ln 2 is equal to ln b, therefore our b must be equal to 2. Now we can put that together with our equation, and we get y is equal to 10 ln 2 ln of 2x. So that is Shari's equation. Then we want to see if when we add them together, we're always going to get the same number, and that number of 50. So we put them together and we get 10 on ln 2 ln 2x plus negative 10 on ln 2 ln 1 on 16x. Obviously we've got a common factor of 10 on ln 2, so we're going to take that out the front. And then we'll have ln of 2x take away ln of 1 on 16x. And then we are able to bring those two ln parts together because we're subtracting, so we'll divide. So we have ln of 2x divided by 1 on 16x. Now if we do 2 divided by 1 on 16, 2 is the same as 2 to the 1, 2 to the negative 4. 1 take away negative 4 is going to give us 2 to the 5. So we end up with 10 over ln 2 is equal to ln of 2 to the power of 5. And then we're able to see how we bring that, we'll bring the 5 down. Oh, sorry, this was actually, oh, I've got an equal sign. That was supposed to be multiply. Shouldn't have put an equal sign there. We're going to bring that 5 down, and then we'll have 5 times 10 over ln 2, and the ln 2 there, and we're able to cancel those ln 2's out, and that will equal 5 times 10 is 50. So the 50, looking back at our table, that is what they were equal to for those 2 days. So we're able to then determine that yes, it will be the same. It will add to the same each time for each day. That's the end of the tech-free paper.